directions here are to divide, so we're dividing polynomials here. And in these first two examples, we're dividing a polynomial by a monomial. So when we're dividing by a monomial, which is just one term, so notice there's one term that we're dividing by, and then over here we have this 9v squared, which is just one term. What we can do is we can write this as 4a cubed plus 4a squared plus a divided by the 4a squared. And this is a common denominator of each of these terms. So we can write this denominator under each term. So we have 4a cubed over 4a squared. Then our plus sign, 4a squared over 4a squared. And then another plus, and we have a over the denominator 4a squared. And now we're going to simplify each of these. In our first one, we see the 4's reduce, and then an a cubed over a squared. Well, we can think, if you remember working with exponents, you subtract the exponents. So we do 3 minus 2 is 1, so we just get an a to the first here. We have our plus sign, and our numerator is the same as the denominator. So when you divide something by itself, it's just 1. And then over here, this one's a little trickier. We're going to have a fraction, so plus a fraction. Nothing reduces with the 4, so that's going to stay in the denominator. And here we can still subtract, but our larger exponent is in the denominator. It's an a squared, and in the numerator, this is just a to the first. So what we're going to do is we're going to think a squared, we're going to do the 2 minus the 1. So 2 minus 1, which is just a. But that's going to go in the denominator because that's where the larger one was. So this is 4a, and we end up, and that's just a 1 in the numerator because we can think, well, that's a 1 times a to the first. And so that's the answer to that one. This next one is similar. And so what we can do, since it's divided by, and this time I'm not even going to really write the first step like this, I'm just going to have 18v to the 4th divided by the 9v squared. Then we have our plus 9v cubed divided by the 9v squared. And then plus the 27v squared divided by 9v squared. And so we can simplify each of these. 9 goes into both of these. This goes twice. And v to the 4th over v squared, you subtract the exponents. So we have our 2. And then v to the 4 minus 2 is 2. Plus sign. 9 divided by 9, that's just 1. V cubed over v squared, we can think, well, that's v to the 3 minus 2, which is 1. And then plus 9 goes into each of these. And then a v squared over v squared, well, that's just 1. Those reduce also. And so you have 3. And so our answer to that one is 2v squared plus v plus 3. These next two, 35 and 36, have a trinomial divided by a binomial. So we're dividing by two terms here. We can't do 35 and 36 the same way we did the ones above that just had a monomial in that spot. So what we do here is we actually do long division. And so we're going to have a division, and we're dividing by x plus 7, so that goes out here. And then we're dividing that into 9x squared plus 65x plus 15. And so we're going to think long division. So we think x times what gives me 9x squared. So I think, well, 9x times x will give me 9x squared. So I figure out what that is, and then I multiply. And I'm going to multiply the 9x times the whole x plus 7. So 9x times x is 9x squared. And 9x times positive 7 is 63x. And so when we do the long division, we multiply, and then we subtract. So when we subtract, we change both signs. So we're going to make this a negative and this a negative. So we're subtracting 9x squared minus 9x squared is 0. That's what we want. That's why we chose this 9x at the top. And so that's a 0. 65x minus 63x is 2x. And then after we subtract, we bring down. That's a plus 15. And now we think x times what is 2x. So we're kind of starting over again. X times what is 2x? Well, that's plus 2. So we multiply 2 times our x plus 7, which is a 2x plus 14. And then once again, we subtract. So when we subtract, we change both signs, and we see we just get 1 here. And so we can put either remainder 1, or better yet, instead of putting remainder 1, we're going to do this like you learned fractions a long time ago. We're going to do plus the 1, this 1, over what we were dividing by, x plus 7. And that is the quotient of that division problem. Let's look at our next one here. We're dividing 5n squared minus 22n plus 9, and we're dividing that by n minus 4. So our n minus 4 goes out here. And we think n times what is 5n squared? Well, we need a 5, and to get n squared, we need an n. So 5n would give me times n would give me the 5n squared. So now I'm going to multiply. Remember, I multiply that 5n times each of those terms there, the n and the negative 4. And then we're going to subtract, so we change both signs. So we have minus. Well, this one was a subtraction, so we're going to change that to plus. Because subtraction is the same as adding the opposite. We get a 0 and then negative 2n. And we bring down our 9. And then we think 9 times what gives me negative 2n? Well, I'll need a negative 2. Then multiply, we get negative 2n. Negative 2 times negative 4 is a positive 8. And once again, we subtract. That changes the signs. And we're left again with a remainder of 1. It doesn't always happen. And so we could put remainder 1, or we can write it as plus 1 over what we were dividing by. And that is our answer.